Okay, here's the situation that we're trying to count today. How many ways can we plan a bookcase? We're given 8 books, 4 shelves. In general, that'll be N books, K shelves. And our plan will be a picture like on the left. It'll have the bookcase shown, 4 shelves, and it will tell us how many books we plan to put on each shelf. So basically we're putting in some blanks that we want to fill in later. We've got 8 books to put on there eventually, so we'll put any number that we want on each shelf. There's the shelves I didn't have room to draw, but they could have all 8 books on one shelf if you want. There's no restrictions here. So on that example plan, I put 3 on shelf 4, 2 on shelf 3, none on shelf 2, that's fine too, and 3 on the first shelf. There's no books yet, just a plan. Now this is the motivation for this is that we'd like to eventually be able to count all kinds of situations where we actually do put the books on, and we put them on in nice ordered rows. Remember in the previous problem we counted, in the last video I believe, we counted the number of ways to designate the shelves to the books, the number of ways to distribute the books on the shelves, so that they weren't ordered yet, but they were in piles just ready to go on the shelf. That's a different problem, and we'll compare them. This time we are eventually wanting to put them in order, but first we need a plan of how many go on each shelf. Alright, so here's the answer of how many plans. We've got 8 identical future book locations to distribute among 4 distinct shelves. So here's how we do it. 2 steps. First we add to the 8 blanks that we have sort of sitting on the side ready to go on the shelves, 3 more. And those are to account for shelf enders or line breaks. We need 3 because there's 4 shelves, so we'll have to insert 3 line breaks. 3 is 4 minus 1 to break up the 4 into 3 parts. So we choose where to put the breaks as step 2. I'll use a little red vertical line. And then we see the remaining blanks as split up into shelves. So that's kind of hard to parse without the example. So here's my 8 blanks plus 3 more. So there's 11 blanks. I just put them lay them on the ground there in a row at first. And then I need to decide how to put them on those shelves. So to do that, I have enough now so that there's room for 3 dividers, 3 shelf enders. And I put them in anywhere I want out of all those 8 blanks. So there's an example. I put in 3 breaks there on blank 4, blank 5, blank 8. And then I look at the blanks that are remaining, the ones that don't have a divider in them, and those are my shelves. I had to decide ahead of time that it's going to be shelf 1, 2, 3, and 4, but that makes sense to do. There's shelf 1, shelf 2 is empty because the 2 line breaks there, the 2 dividers, are right next to each other, so there's nothing for shelf 2. Then shelf 3 has 2, and shelf 4 has 3. That was the picture we drew up above. So you can see that if we wanted a different plan, we could show it by starting with a different placement of the breaks. Okay, so here's how that turns out to count. The 3 breaks that we put in are identical, so that means we can choose them order free, and that means we use the combinations. We want just any subset of those 11 possibilities to put the line breaks in, to put the shelf enders. So the number of plans will be 11, choose 3, written like that. The 11 comes from 8 plus 4 minus 1, and the 3 comes from 4 minus 1. And the number turns out to be 165. In general, n books on k shelves, the number of plans, giving the number of books planned for each shelf, is n plus k minus 1, choose k minus 1.